Uh, Hi everyone, welcome back to my channel. And in the previous lecture, we talked about the natural gas industry. In this lecture, we are talking about the gas processing. What is it? How it is done? And what are the major processing units that are installed in the gas processing plant? So let's start with the first thing that what we have, what you want to know. The first thing you need to remember that the gas is obtained from two different kind of reservoirs. One is the pure gas reservoirs, which has no oil, and is we call it a dry gas reservoir. And the other one is the wet gas reservoir or gas reservoir, which has the oil uh, parts, oil is mixed with it in the simplest form, or you can say. So it can be called the two-phase reservoir, which has oil and gas together in a combination. So we have two different kind of reservoirs, and based on whatever composition we get, we design our plant. As we discussed in the previous lecture, that whatever plant we are designing is actually based on what kind of composition we have. So let's look at the number first thing, like uh, about the gas processing is the gas specifications. Well, there is an uh, company, oil company, which is producing the gas. Then there is a customer who is buying this gas. So the customer who buys this gas provides the gas specifications, like what is his requirement, what, and when they do the contracts and when they finalize the deals, what are the parameters or specifications that are checked in the gas contracts. Well, the number one important thing uh, for the gas processing plant is the pressure. What is the minimum, maximum, and delivery pressure? Because there are many plants that operate at minimum pressure. They have their pressure requirement, minimum pressure requirement. So when they buy the gas, they have to look at the pressure of the gas. For example, if the pressure of the pipeline or the gas they are receiving is not enough, then they have to install their own compressors and they have to maintain their own compression unit, which costs lots of electricity and operating cost at the same time. So it's a cost. Therefore, when they buy the gas, they look at it. First thing they look at it, whether the gas they are buying is meeting the requirement or not. This is the first thing. Then after that, the second thing is the formation of water. There are many plants, many processes that do not need water, and water can create problems inside those plants if the two phases are created. At the same time, this water is a problem, is a major cause of corrosion inside the pipelines. It can damage the pipeline because of corrosion. And again, if there's a temperature is sub-zero, and if the temperature is too low, and it's cold weather, and it can cause the hydrate formation. So it's another flow assurance issue comes up because of the water. So we don't want water. We look at it how much water it has inside the gas. And then the third point, which is the heavy hydrocarbons. What is the heating value of this gas, and what are the heavy hydrocarbon component it has, and how much they are in? Because if they are too much, again, they can settle down, form the separate phase, and the two phase can be formed. So they have to look at it whether is it acceptable or not. So this is the third thing they look for it. Then the another thing they look for is the contaminants. For example, uh, how much oxygen it has, how much the helium it has or mercury it has. We are more strict about the H2S because H2S is very toxic and it can cause damage. No, it not only cause the corrosion, but it can be very much harmful for human inhaling, and even the person can become unconscious because of the H2S. Then another important parameter is the heating value. Like what is the heating value of the gas you are selling? So when you decide the price of the gas for buying, you consider all these main factors, especially the H2S content, heating value, any heavy hydrocarbons, water content, what is the pressure, delivery pressure, and these are the main conditions that they are looking at it. Other than this one, they look at the temperature of the gas also. What is the temperature of the gas? And that also plays a very major role in the price and the contracts at the same time. Apart from this, these technical parameters, the properties of the gas, there are many other factors that matters. For example, the the price of gas here in Kurdistan is different, but if you go to any other country, it is different. So it also depends on how far you are from the major market. Your buyer is far or close. For example, somebody is sitting in Russia and he is buying the gas in Europe. So how you are going to transport? What will be the transport cost in the behind it? So definitely the geography, the market accessibility, and the duration of the contract. Because, for example, if you are doing the contract for 1 year, the price of the gas will be different. But if the uh, contract length is 10 years, then the price of the contract will be different for the gas. So these things definitely matter when you go for the in the gas contracts. Okay. Then there is another story uh, about this gas processing plant. That what are the major uh, processes that are done in the gas processing? Well, number one uh, is the compression. We require compression at many stages. And why we need require the compression? Because in order to transport this gas through the pipelines, the pressure has to be maintained. Only using the pressure we can send this gas at the long distances and so on. So this pressure, but first of all, we have to look at it where actually the pressure is reduced. So, for example, look at this a very nice diagram. Here we have the reservoir where the gas is coming out of this reservoir. When it reaches to the reservoir production separator, the pressure has declined. Pressure probably here is 100 psi and so on. So, in order to send this gas from the separator to the gas processing plant without increasing its pressure is not possible. So what we do, we install the compressors here, which actually increases its pressure, and we send it to the gas processing plant. But remember, at the same time, when we do the gas compression, it increases its heat, and it generates lots of heat, and it increases its temperature, which is also sometimes is not desired by the gas processing plant. So what we do, we actually use some heat exchangers in order to reduce its temperature. Apart from this compression here needed, we have again from the separator, when the separator uh, oil is separated, but when this oil is stabilized, it also some gas is released, so we put another compressor here. Again, after the gas processing, when you are sending this gas over the long distance pipeline, these compressors are needed. So first, the major plant process and major cost of the not only the capital cost but the operating cost of the gas processing plant is the maintaining the compression, because these compressors require a lot of electricity. They are running 24 hours then, because they have to maintain the pressure using this one. So as we said that there are two kinds of gas reservoirs, associated and non-associated. And non-associated gas is normally produced with crude oil. Is it correct or not correct? Well, the answer is it is false, because the gas that is produced with crude oil is, we call it associated gas. That's why this statement is false here, as we mentioned. Non-associated gas is the one which is free, so it is not associated with anyone, and so on. So as I said, the first major process in the gas processing plant is the compression. We install big compressors, and these compressors are helpful for maintaining the pressure needed for the plant. As I said, these gas compressors are needed for transportation over long distances. This is also needed in the, and also in sometimes in order to keep the fluid in dense phase, we need the compression units also. As I said, these compressors, they when the gas is compressed and it generates lots of heat, the volume and temperature are opposite to each other. So this heat has to be cooled down, because many processes work more efficiently at lower temperature. So we have to reduce its temperature, and for that we use many ways to reduce this temperature. For example, we have the simple air heat exchangers. Sometimes we use the Joule-Thomson valve, JT valve we call it, or JT throttling, or sometimes we use the refrigeration, mechanical refrigeration. They are like the chillers that we have at our home, just they are bigger in size, and they are used just to cool this gas and using the mechanical compressors, mechanical machines. So these are the ways to cool it. So after the compression, the cooling is needed so that we can process this gas. This is the heat exchanger using the air. This is the normal uh, perform a normal form of the heat exchange and reduction of gas, which is reduction of temperature in the gas, which is happening here. Well, cooling to sub-zero temperature, we use definitely turbo expansion in order to use these turbo expansion. In order to keep the transport the gas from over the long distance pipeline, definitely we need the compressions. This is again correct as it mentioned here. Then after the compression, the second important process that we have in gas processing is dehydration. As I said that the water is not desirable product. And if you have water in your gas and you are selling it, it reduces its heating value first of all. Secondly, it can cause corrosion. And if the corrosion happen, it can cause the leakages. And thirdly, if the temperature weather is very extreme in the regions, it can cause the hydrate formation. Hydrates are actually ice-like materials and they are actually an ice crystals that are formed, and it reduces the efficiency of the flow. That's why we are not in need of this hydrates or water. Therefore, we have to remove this water. Now, the process of removing this water, we call it dehydration. Remember that we have two kinds of water with the gas. One is the associated water and another one is the non-associated water. Or you can say that free water or water vapors. Free water is actually removed at the separator. When we have the separation production and production facility, we remove this free water. But sometimes the water is in the vapor form in the gas, which is mixed with the gas in the as a vapor. This form, simple using the density principle or simply using the separators, cannot be removed. So in that case, we use the gas dehydration plant. We have a complete process which is used to remove this gas uh, water from this gas. Now, this plant is called the glycol dehydration plant. We have the glycols that we use, and we will discuss them in the coming lectures about gas dehydration a lot. Then, after the removal, compression, the gas dehydration, we have another part of the plant. We call it a sweetening plant. The purpose of the sweetening plant is to remove any toxic gases, for example, H2S. H2S has to be removed. As we say, it's a health hazard. If the person can die if he inhales the H2S. So it's a very acidic and toxic gas. We are not need this gas is not needed. So it has to be removed. Apart from H2S, we have to remove the CO2 and many other impurities. For example, helium, mercury, oxygen, nitrogen, all has to be removed. But the process to remove H2S and CO2 is called the sweetening plant. So after the reservoir production facility, we have compression. We remove the water, then we remove the H2S and CO2 out of it. As I said, H2S is very corrosive. It can attack carbon steel pipelines, toxic. It can really be dangerous for humans at the same time. The problem with this carbon dioxide is not that toxic as H2S, but the problem is it reduces its heating value, and it is not desirable because it just reduces the heating value, and we have to remove it from the gas from the gas. Then after this gas compression, gas sweetening, gas dehydration, we have NGL recovery, natural gas liquids. In this case, we have this natural gas liquid recovery is actually we control the dew point. Now, what is the dew point? When first drop of liquid is formed inside the gas, that is called the dew point pressure or temperature. At pressure and temperature at which the first drop of liquid is formed is called the dew point. So by controlling the dew point, we can actually play with the temperature and remove all these liquid hydrocarbons out of it. Again, it requires a process. So this is in question that should we remove it or not? This is the question that we need uh, to to answer based on the economics of the project. Then after the NGL recovery, these NGL, as I said, are propane, butane, pentane, hexane, octane, nonane. So these has to be removed if they are in big quantity. If they are in big quantity, we remove it and we sell them. If not, they are not in big quantity, we keep them as it is because they are good for the maintaining the heating value at the same time. Then this is the main NGL tower where we will discuss that in much details in the coming ahead. So this is the mechanical refrigeration, warm reservoir and liquid storage and so on. So apart from this gas sweetening, gas hydration, natural removing the natural gas liquids, uh, removing and the compressors. Apart from them, we have one more topic that we will discuss in the upcoming lecture is about the LNG. LNG is actually the same natural gas we are discussing here, but it is in liquid form. And it is not naturally at liquid form, but we play its properties. We play with its critical properties, and we maintain its temperature of minus 161 degree Fahrenheit and minus 161 degree centigrade to cool this gas that much so that it becomes a liquid, and then we transport using the bowsers and trucks, and we can again gasify it and so on. So we will discuss that one also. Then we can discuss the nitrogen rejection. Nitrogen rejection has a separate plant, because nitrogen rejection actually also reduces the heating value, so we have to remove this nitrogen also at the same time. And so there are a number of processes that we will discuss one by one, and much details about plants and their designs and their troubleshooting, what kind of problems they face, what kind of apart from that, we will discuss the parameters, their parameters that are needed in the gas plants, and so on. So thank you very much for this lecture. Hope to see you in the next lecture.